Today's topic of our webinar is Mission Critical Solution in Electricity Transmission and Distribution Network. We will be focusing on the solutions that Korenix is able to provide in the electricity segment and related market. By the way, my name is Jacqueline. I am the BDM in Korenix Technology. Good day to everyone that is joining this webinar. Okay, let's start with the outline of today's webinar. First, I will be giving a brief introduction about the whole system infrastructure in the electricity transmission and distribution in the whole network that this electricity market is using nowadays. Okay, give you a brief idea, a brief concept of the infrastructure. And following by that, I will be sharing two cases that Korenix is able to do with our partners in such infrastructure, in such system. Followed by the featured products that is introduced in the two cases. I will be sharing a few features about those products. Okay, I will not give too many information in this webinar, just to keep you noted that Korenix is able to give what kind of solution to our partners and what kind of product has the advantage to such application. Okay, let's start by system infrastructure. Any system that is related in electricity transmission in energy a segment can be simplified as generator and consumer. That is the most basic fundamental in any energy segment or any network, energy network. A generator, which in this illustration is the battery, and the consumer is the light bulb. As you can see, this is a very simplified topology in the infrastructure, that the battery is providing energy, providing power, electricity to the light bulbs. And for the light bulbs, as known as consumers, there are small consumers like us, like houses, like small stores. And there are bigger consumers such as public utilities, like government departments, like wastewater treatment center, etc. Those are requiring more power than the usual consumers. Okay, you have small light bulbs and a bigger light bulbs. To take it to the next level, to the next step, we need protection on these network, on these topologies, to protect the loading, the energy loading of the whole network, and also the devices at the consumer side from the overload impulse of the power. And therefore, you have the circuit breaker protection, either on the main network, as well as the local field side network, as the main network and the field side network, as you can see in the illustration. Okay, now we have the circuit breaker protection to make it more similar to the actual circumstances. You will have not only a dozen, but millions of light bulbs in one circuit, in one power circuit. You will have millions of consumers in the same infrastructure, and naturally the distance that the energy have to travel will become longer and longer. So more power requirement and a longer distance that has to travel for the energy. Okay, so how do we solve that? How do we make this illustration be more realistic to our real life? The battery becomes a power plant to generate enough power for the millions consumers that requires electricity in their houses, in their factories, okay? You have a power plant to generate the power. And then because of the long travel distance, the power loses over the distance, okay? The current, the power decrease throughout the travel transmission in the network. And therefore, the solution is to step up to increase the voltage of the electricity before it travels the long distance, and then decrease it when it gets to the local side, when it gets to the consumer side, to adopt the voltage acceptable range of the local device, or in our houses or in the factories. Okay, so the transmission network, the purpose of the transmission network is to adjust the voltage to prevent the power loss and to adopt the voltage required low voltage range of the local device. Okay, that's the purpose we need to have in the transmission network, including multiple substations. Okay, so in real life, in reality, there are different voltage levels along the transmission network because of the different requirement of the consumer. Some consumer, like a bigger factory, requires a higher voltage to power up the whole factory. And some, like a convenience store, like a department store, will require a middle range of the voltage. And the other, like a small consumer, like the houses in our home, we will require the bottom level of the voltage range. And therefore, you have a different substation along the network to adjust the voltage to different level and to provide a suitable voltage range to the respectively corresponding consumers. Okay. So therefore, you have this illustration with the actual network infrastructure in the electricity system. First, you go from power generation, to the power transmission, and then power distribution. Okay. In generation part, we have conventional power plant as well as renewable power plant, like wind power or solar power. Okay, when you generate the power from the power plant, you transmit. You go to the transmission phase and you transmit the power via transmission network and transmission substation with corresponding different voltage level. Okay, from 800K to 132K. And then you go to the distribution phase. You have the grid substation with 33K voltage, and then you distributed the voltage, the power to either industrial consumer or general consumer, okay, based on different voltage level requirement. Okay, these numbers in voltage are for a approximate number as estimation, because for different country, different region, it will differ from different requirement. Okay, as I said from the title, today's topic is about transmission and distribution in our system infrastructure. Therefore, I will be focusing on the core, the center part of the whole network, which is transmission network and the substation application. Okay, from these two different parts, I will be sharing two cases that we have successfully done with our partners in this application. Okay, transmission network and substations. Okay, so let's move on to case sharing. For transmission network project, normally these electricity towers or field site facilities, as you can see, are often on the very remote side of the country, okay, whether it's a forest or a desert or whatever very field site of the country, that is impossible to build a wired connection with the facilities on that field site. Therefore, you must have a wireless connection, wireless communication to receive the data and to control those units from your control center, from your server. Therefore, a remote wireless connection is essential in such application. And in this project we have in Middle East, we installed our 4G LTE cellular router. The model name is JetWave 2414. This cellular router is able to connect the control center with the local devices such as RMU, the ring management unit, an embedded PC, and voltage meter. The RMU basically is a switch to turn on and off the route, the electricity route, to transfer the electricity from one site to another. And the embedded PC, obviously, to do some edge computing, to do some local data storage and processing for the devices at the field site. Well, some embedded PC itself has the ability to communicate via 4G LTE network, but some doesn't. In this case, in this customer, it does not equipped with such function, and therefore they need our cellular router to fulfill this wireless connection for their embedded PC. And the third device is the voltage meter to detect, to monitor the voltage that is coming through the local site. Obviously, this is very essential. This is critical to monitor this data. And this is connected to the serial port of our device, as well as the wireless connection to the server to monitor the voltage at all time. Okay, so a very elegant and simple connection that enables all these devices in the desert, in the forest, to communicate with the server seamlessly using our 4G LTE cellular router that in this case is equipped in the middle of a desert. As you can see, this is an illustration of the actual field site. Our cellular router has been fully technically approved by our end customer to be used in such harsh environment. This gives you a basic idea of how ruggedized our devices are to survive in this area, in these regions. Okay, fully industrial grade designed devices to tolerate any extreme weather or circumstances. All right, this is the application for transmission network. The second case sharing is for substation. In this case, in this project, our system integrator installed our switches into the whole substation network infrastructure. In a standard substation network, there are 3 levels within the infrastructure. The first is the station level, which you can think of it as a control center. And the bay level is the middle layer to control the end device at the bottom level. Okay, the IED is the intelligent electricity device to control and monitor the devices at the process level. At the process level, there are multiple kinds of equipment, such as intelligent switchgear and relay and power meter to monitor the power, obviously. Many different kinds of devices that are installed in a substation for the purpose of adjusting the voltage, as I said in the infrastructure introduction, as well as protect the whole circuit, protect the whole network for breaking down and for unexpected accidents. Okay, so that's the purpose that we equipped these devices in the substation. And to connect them into a secure network, our system integrator uses JetNet 6828GF of Korenix portfolio that is able to provide a secure network with redundancy design to fully protect this kind of mission critical application. Any application that is related to power, to energy providing, is critical, is essential to countries, to consumers. So this kind of network has the top priority for security and redundancy. Failure is not an option in this kind of infrastructure. So the switch is very important to provide a redundant and secure and reliable network for such application. For the station level, as I mentioned, it's a control center. Actually, this is one station in the whole substation. However, there are multiple stations in one same substation. Therefore, there will be many different stations that has to link together. Here's an illustration in the substation I was saying. As you can see, there are hundreds of intelligent switch gears in only one room, in only one station of the substation. Therefore, to connect them all together using one fiber ring is the application that we have done in this project. The purpose is that to prevent any network failure from the bay level to the station level. Once there's any connection failure, the fiber ring ensures that another station's control center still receives the data from the bottom side, so that they can monitor the data from another station, as well as to maybe pause or give any urgent direction to the devices and wait for the failure to recover or to have a backup plan. Okay, so this redundant ring is essential to provide a emergency solution to such mission critical network. Okay, so in this whole substation, we provide security function and the redundancy function to the whole substation to form a reliable network. Okay, that's for the two cases that I would like to share today. And now we're entering the featured product. Okay, the first highlight featured product is the JetWave 2414. I was introducing this model in the first cases of the transmission network wireless connection. Let's take a look at the highlight features. First of all, it supports dual SIM card redundancy that ensures non-stop connection for critical data transmission. It has two SIM cards to be installed in these devices, and when you install two different SIM cards from different telecom provider, it ensures you have a backup connection from another telecom provider in case of any connection failure from the provider, from the network connection. Okay, so a redundancy design for the devices to ensure a non-stop connection. All right. The second feature is the passive PoE that accept power from its Ethernet port to simplify your power arrangement in the field site. If you have a power feeding device already existing in your field site, you can connect that feeding device to this JetWave model to have the power from that device to prevent you from the trouble of arranging another power supply unit in the middle of the desert. Okay, so very convenient design to receive power from the Ethernet port. The third feature is that it supports GPS function for location tracking in transportation-related application. Obviously, in this case, we're using it alongside with the electricity tower. It doesn't move so that we don't need to check its location. But in case you are using this in any transportation solution, like you are tracking a truck or a bus or any moving object, it is very convenient to track the location via its GPS supported function. The last feature is that this is a very flexible series selection, that it comes with 2 or 6 port, as well as different LTE transfer speed for category 1 or category 4. In this model, JetWave 2414, it's a 6-port device with the LTE Cat 4 speed. Okay. So a flexible option for your project that we can customize it for your desire, for your requirement. Finally, the last featured product is our JetNet 6828GF, which is used in the second case, the substation case sharing. The first highlight is that this is a layer 3 managed switch with advanced cybersecurity functions like access control list, DHCP snooping, and dynamic ARP detection. I will not go into the detail of these cybersecurity functions, but the basic concept, basic idea is to do authentication to prevent an unknown access or an unknown attack from the outside to the local private substation network. Okay, if I don't know you, if you're not in my approval list, I will reject your access, either coming out or going out or coming in. So this is the basic concept to protect a local private network. Okay. The second feature is that it supports advanced redundancy technology, including multiple super ring, as well as super chain, and the ERPS function, which is capable to form a standard ring with a third-party switches or third-party devices. Okay. These redundancy technology offers a flexible topology design ability for our system integrators to design a customized ring topology to adopt their project requirement. Okay, we support multiple kinds of ring for you to design your own requirement of the ring, whether it's connected to multiple rings or one ring with many devices, or in one ring with multiple connections. Everything is capable of doing so in this device. The third feature is that it supports IEC 61850-3. This is a very standard electricity segment certification that certifies such equipment to be used in an environment that has so many electricity influence in the environment that this device is still capable of function normally. And the second feature, the second certification is IEEE 1588v2 PTP, the Precision Timing Protocol. It basically it supports the precise time stamping function designed by hardware along with the data transfer, okay, which is very critical and very convenient in the electricity data transmission. Okay, that's it. That's the basic concept that I want to deliver to you guys in today's webinar. That Korenix is able to do these kinds of fundamental and critical solutions in electricity segment. So that the purpose of today's webinar is to remind you guys and to inform you guys that if you ever face a similar project in your business, a similar project in electricity market, in electricity projects, we are very capable of providing a high quality solution with our top tier level of devices. Electricity market is normally known as a public sector in almost every country. And therefore, the competition is very, very tough because of it's a public sector and the public center, a public tender. Normally, there will be many, many competitors. Despite that, I want to encourage you guys to consider Korenix as your partner to work with you in this kind of project in your future business requirement. Okay, I think that will be all for today. Thank you for your participation.